The last method we're going to use to solve systems for these linear equations is called the addition method. Sometimes it's also called the elimination method. You'll hear me call it elimination, mainly because that's how I learned it a while ago. And it's hard for me to start calling it by a different name. So you'll hear me call it the elimination method. And when we're working these systems, I just want you to keep this in mind. If you have one of your equations that's already solved for x or y, I'm going to use substitution because it's already set up that way. I'm going to use this addition method or elimination if I have two equations where x and y are both on the same side of the equal sign. And that just is my rule of thumb. I am not picky about how you solve these equations. I just want you to be able to solve them. So you will use whichever method that you want to use when you're working homework. But sometimes they're set up easier for one method or the other. So on these, what we do is we're going to, first of all, we're going to line up our x's and y's and make sure x's are lined up on top of x's, y's are lined up on top of y's. And then we're going to look at each individual pair of x's and y's. And you're going to see if you can line them up to where when you added straight down, one of the variables would cancel completely out. We're going to have to manipulate the equation sometimes in order to get that to happen, but it's not very difficult when we get it to happen. I'm going to come over here and I'm going to show you an example on the right-hand side. So if I have x minus y equals 5 and x plus y equals 7. Now, these are lined up. My x's are underneath my x's, my y's are underneath the y's. If I added straight down with this equation, my y's would cancel completely out. And I would have x plus x, which is 2x. Don't forget to add the x's. 7 plus 5 would be equal to 12. I'm going to keep going and solve for x. So divide both sides by 2. So x equals 6. That is the ordered pair part, the x part of my answer. Then I would go back and put the 6 into one of the equations to figure out what y is. So I'm going to use the top one. 6 minus y equals 5. Subtract 6 from both sides. So negative y equals negative 1. So that means that y must equal 1. So 1 would be the y part of my system. That's one where we didn't really have to manipulate any equations. They were strictly set up already. The y's canceled. You move on. You solve for x. So the number 1 that they have here in the workbook is a little bit different. If I were given this problem straight as it is, I would automatically go to substitution because I've got y already solved for 13 minus 3x. Now, for our purposes, I'm going to rearrange this equation so you can see what they look like to do elimination. So the 3x needs to move over. So when I bring it across the equal sign, it's going to become a positive 3x. So I've got 3x plus y equals 13. Now I need to write the second equation underneath it where I've got x's and y's lined up. And notice they have y coming first and x coming last. So be sure you line it up with the correct signs. Copy your signs correctly. But make sure that, and that's a negative 8, make sure that your x's or y's are lined up. Now you will see that if I added straight down as these equations are right now, neither x or y would cancel. Okay? But I can manipulate one of the equations and kind of force it to be an equation where if I added, they would cancel. Now, what I'm going to do is I'm going to look for one of the equations, just like I did for substitution when I chose an equation that had either a 1x or a 1y in it. I'm going to look for that first in these. In this case, I have a 1y up in the top equation. Underneath it is a positive 9. If that y in the top equation were a negative 9y, then those y's would cancel. I hope you can see that and agree with that. Well, I can make it be a negative 9y if I multiply and made it a negative 9y. Well, I can't just multiply the y in the middle. I'm going to have to multiply every term in that equation by the -9 in order to get that to be a -9y for that just that one term. So I'm going to do that. I'm going to hippity-hoppity distributive property. So I'm going to have -27x minus 9y equals -9 times a 13 would be -117. And then just rewrite the other equation underneath it. We didn't do anything to the second equation, so I'm just going to write it underneath. And then now you can see that if I add straight down, the 9y's would cancel because one's a negative and one's a positive. I'm going to continue with my x's. -27 plus 2 would be -25x equals -117 and, -117 and a negative, I was writing what I was saying. -117 and a -8 is going to give me -125. Divide both sides by -25. So x equals 5. So I know that x equals 5. You can go back and use either equation for your x. So my ordered pair, let's see if I can do some separation here. My ordered pair for this one, I'm going to get 5 for the x. So I'm going to come over here and I'm going to say, okay, to get y, I'm going to say y equals 13 minus 3x. So y equals 13 minus 3 times 5. So that's 13 minus 15, which is -2. Now this problem should look familiar because it's the very first problem we did in the last section when we used substitution. So you can see we get the same answer either way. Excuse me. You get the same answer either way, but I would have used substitution on this one, but since I'm showing you elimination, I wanted to line them up. Now, the second equation on this page, definitely one that I would use elimination on because they're already set up with your x's and your y's stacked on top of each other. My only problem with it is that I have an x on top, a minus 4x on the bottom, a 3y, and a 4y. So do you agree with me that if this x were a 4x on top, then those x's would cancel? Well, I can make it be a 4x, but I have to change every term in that equation. So I have to multiply them all by 4. So that's going to give me 4x plus 12y equals 4 times 27 is going to give me 108. And then I'm going to rewrite the other one underneath it. -4x plus 4y equals positive 36. Now, if I add straight down, my x's would cancel. 12y plus 4y is giving me 16y. 108 and 36 is 144. Divide both sides by 16. So y equals 9. So my y portion of my ordered pair answer, and you have to type all these answers in as ordered pairs. My y portion is going to be 9. Now I'm going to take my 9 and I'm going to put it in. I'm just going to pick the first equation. And I'm going to have x plus 3 times 9 equals 27. So x plus 27 equals 27. And if I subtract 27 from both sides, I get x equals 0, which is okay. That just means I've got 0 in my ordered pair. So my ordered pair answer would be 0, 9. Okay, let's look at some on the back. Okay, on this first one, I've got x plus 2y equals 8. So again, it's got a 5x underneath it. I'm going to work with that x. If that were a -5x, they would cancel. So let's multiply the top equation by -5. So I'm going to have -5x minus 10y equals -40. I'm going to have 5x minus 2y equals positive 4. We're going to add and cancel our x's. -10y minus 2y would be -12y equals -40 plus 4 would be -36. If I divide both sides by -12, I'm going to get a positive 3 for my y part. So I'm going to come over here. I'll put 3 over here for y. And then the top equation just looks easier to me. You can use either equation to figure out what x is going to be, but I'm just going to use the top one. X plus 2 times 3 equals 8. I'm using the 3 because I just found that out for y. So x plus 6 equals 8. Subtract 6 from both sides. So x equals a 2. So 2 goes in for my x. And there's my ordered pair answer. Okay, let's move on. Let's do the next two. They're all pretty similar once you get the hang of doing them. Now on this one, I have a negative 2y on top and a positive y on the bottom. So this time I'm going to use the bottom equation. And if it were a 2y in the middle, they would cancel. So I'm going to multiply that equation by 2. So in this case, the top equation stays the same. And I'm going to multiply the bottom equation by 2. So that's going to give me 6x plus 2y equals 18. Now the most common mistake is you will not multiply every term by that number. So be very careful when you're doing this. Make sure you write them out very carefully, and that way you won't get messed up. 5x plus 6x is going to be 11x. My y's cancel. 4 plus 18 gives me 22. So I've got 22 divided by 11, which is 2. So 2. And then I'm going to come up here. I'm going to use the bottom equation and use my 2 in there. So 3 times 2 plus y equals 9. So 6 plus y equals 9. So if I subtract 6 from both sides, y equals 3. So 3 is what I'm going to get. So far, not too bad. Let's look at the next one. If you'll look at the next one, you can see I've got 7a plus 2b equals negative 1. 3a minus 4b equals 19. I don't have a 1a or a 1b in this particular problem. So I'm going to have to look to see if I can make either one of the pairs match. The next thing I'll look for is if I've got numbers that have common factors. So I see the 2 and the 4. It's easy to multiply 2 by 2 to get me a positive 4. If this were a positive 4 right here, then when I would add straight down, the b's would cancel. So in this case, because it's a and b, a is going to come first and b is going to come next. That's a little odd too because we haven't done a's and b's. So I'm going to multiply this top equation by a 2. And then that's going to have them lined up where I'll have negative 4b and positive 4b. So that's going to give me 14a plus 4b. That's an a right there. Equals negative 2. And I'm going to have a 3a minus 4b equals 19. So you can see the b's cancel now. 14 plus 3 is going to give me 17a equals negative 2 plus 19 would give me positive 17. Divide both sides by 17. So a equals 1. So we'll put that over here. And so on this particular one, it doesn't look like either one of them is any easier. I'm just going to randomly pick the top one. So 7 times 1 plus 2b equals negative 1. So that's 7 plus 2b equals negative 1. Subtract 7. So 2b equals negative 8. Divide by 2. So b equals negative 4. Put that in my ordered pair, and there's my answer. I'm not going to worry about working this last one because it's very similar to the other ones. You just need to make sure you line them up. Now, one thing that I will tell you, if you have something like this, and this is one that I'm making up, so it will not have nice answers. I just want to show you the beginning part. If you were to have a 2x plus a 3y equals 9 and a 3x plus a 2y equals negative 7. I'm not working this one all the way because I made up crazy numbers. But you can see here, I can't multiply 2 to get a 3 or anything. So on this one, what I would do is I would say, okay, what is an LCD between 2 and 3? Well, that would be 6. So if I can make the top one into a 6, I'd have to multiply by 3. Well, I need a negative 6 on the bottom, so I would have to multiply the bottom equation times a negative 2. That way, on the top, I would have that 6x plus 9y equals 27. And then on the bottom, if I multiplied, I'd have negative 6x minus 4y equals 14. And then we would go from there. And this one is going to come out to be a crazy fraction. But you see on this particular one, neither one had an easy way to make them into the other number. So I had to multiply both equations in this case. That will happen every so often. Most of them are going to be set up kind of like the ones we did. You just have to multiply one of your equations. But just watch out for that on homework. And if you get stuck, remember, always click on that envelope so that you can send me the problems that you're stuck on, and then I can help you out with that and help you see what you need to multiply. Have a good day.